Hey guys, welcome back to AlgoYogi. We're doing array and hashing series, and our next problem in the list is find all numbers disappeared in an array. So let's go to LeetCode, and there we go. Given an array nums of n integers where nums I is in the range 1 to n, return an array of all the integers in the range 1 to n that do not appear in nums. So that means some numbers have reappeared, they are duplicate numbers, and because of that, like there are some numbers that are not present in this array, and that's what we have to return. So basically this is the first example that I have taken, and we are given nums, and here these numbers are in range from 1 to n. So the range is 1 to n. So that means if I mark all the indexes here 0, 1, 2, 3, 4, 5, 6 and 7, so that means I was supposed to have numbers in the range 1 to n, which is the length is 8, so 1 to 8. So that those are the numbers I should have seen. So basically I should have seen 1, 2, 3, 4, 5, 6, 7 and 8. Well, what are the numbers that I'm seeing? Well, I'm seeing 1 right here, I'm seeing 2 right here, so right here 2, so I'll just mark all of these. So 2 is there, 3 is there, 4 is there, 4 is there right here, 3 is there. How about 5? Is 5 there? No. So that will go to my result. So 5 is not present. Then how about 6? 6 is also not present. How about 7? 7 is present, and then 8 is present. So that means 2 numbers are not present. That means 2 numbers have been repeated. So you can see the repeated numbers. 2 is repeated, and 3 is repeated. Right? So because of those 2 repetition, we don't have 5 and 6. So for that, it's easy. For brute force solution for this problem, brute force solution would be, how about you simply just make the set of this. We'll make the set of all the numbers. So I'll just have a set, and I will just put into my set all these numbers. Okay, so I'll just call unique nums would be set, and let's put the nums here. So this will give me all the numbers that are unique here. So it will give me 1, 2, 3, 4 and 6, not 6, sorry, 7 and 8, and not 6, by the way. Let's remove this, not 6, 7, 8. And then I can simply run a for loop for I in range from 1 to n plus 1, right? Or not n plus 1, I would say yes, n plus 1 if n is the length of this num. So n is the length of this nums. So I will run this, and if this I not in my unique nums in my set, then I can just add this to my result. So I'll have result and empty array, and I will append that to my result, and then I will return my result. So that's the brute force solution. Easy and simple. So this solution here is of time complexity big of n, right? Because you are just visiting all these numbers just once, and then because these numbers were supposed to be in this range 1 to length plus 1, right? Now what about space complexity? Space complexity is big of n as well, right? Big of n as well. So can we do better? Although we will, because this time complexity of n is great, that's the best you can do if you have to see all these numbers. But for space complexity, we can definitely bring it down to a constant space complexity. So how do we do that? So let's move to a more optimal solution. By the way, this brute force solution, this should run. You can go and implement this. This is also a pretty good solution. Now let's bring down the space complexity. Okay, so I will use the fact that these numbers that I'm seeing in my array, let's say that the index range of these nums is also in the range 0 to n, if n is the 0 to n minus 1 actually. So the index range, what is my index range? Index range is 0 to n minus 1, and my numbers range, my num range, the numbers that I'm seeing, num range is 1 to n, right? 1 to n. So I want to use these two properties. That's index range is this and num range is this. How can I do that? What's common between these? Well, everything is common. It's just this number. If I want to convert this number to index, then I just have to decrement 1. So all these numbers from 1 to 3 till n, if I want to convert these to indexes, then I'll just have to do the num minus 1. That's basically go up to the index range, right? That's the mapping that we are seeing. So what I'll do is all these numbers in my array also present the index. So what I will do is, rather than having this set and of these unique values, what I'll do is I will visit all these numbers, or I will visit all these numbers, and for each of these index, what I will do is, let me just remove this. What I'll do is simply I will visit that index. So let's say I start visiting 4, and at that index, and I'm gonna just make these empty values so that I update those. So 0, 1, 2, 3, 4, 5, 6, and 7. Okay, all these numbers. So what I'll do is 0, 1, 2, 3, 4, 5, 6, and 7. These are the indexes. At fourth index, although I will basically go 4 minus 1 because these are numbers, and we just discussed the mapping is like that number minus 1. That's the index it actually points to. So all these numbers, currently I want to use this index as a representation of that number. So what I'll do, how do I mark that I have seen the index that was supposed to be in an original array? This could be my array, just plus 1 each of these index, right? So what I'll do is, how do I say that I have seen 4? How do I say that I've seen 4? So what I'll do is I'll go to this index in my array. This is nums only. Remember, this is nums itself. Okay, this is nums. So what I'll do is, in my nums itself, I will go to this index minus 1, 4 minus 1, which is 3, and I will convert this value that I have right now, which is 7. I will convert this value to negative value. So I'll convert this to negative value, and that is the representation that I have seen the number. I have seen the number at this index, the index it was supposed to be. Okay, not supposed to be in this original, but let's say if this was sorted, it was sorted array. And then I will go 3. I'll go to 3. The reason I'm converting this is, like, let's say if there was a perfect array, and that would look like 1, 2, 3, 4, 5, 6, 7, and 8. This is how a perfect array would look like. So at 4, that I have seen 4, so I will go to this index, third index, fourth index is 3, because index start at 0. So I will mark this negative number. Okay, then I will go to 3 minus 1, 2. So I'll mark the value at 2, negative 2, and then I will access this value. So remember, I'm not just accessing 2, I'm accessing negative 2, because I have already converted this, because when I was at index 1 and I saw that value 3 minus 1 2, and at second index this value I have converted to negative. So that is why when I'm accessing this value I will use the absolute value. Okay, then I come to 2 minus 1 1, so that means I have seen 2, so I will these all values are seen, right? All values are seen. Then I will also mark this, basically the value right here as negative. So this 3 I will mark as -3. Then I go to 7 minus 1 6 right here, 6 right here. I will say that I've seen it. So at 6 it's -3, so I will say -3. So I've seen 7 as well. Then 8, for 8 minus 1 7. So let's go to 7th index right here. So that means here it's 1, so I will convert it to -1. That means I've also seen 8. 8 is also seen. Then I go to 2 minus 1 1. Then I come here and it's already negative, but I will again convert this to negative, doesn't matter. Okay, yeah, so if I will convert this to negative, then I will go over here, but also I don't have to reconvert this value, but this value is, if it's already negative, I don't have to convert it. Okay, I'll make a check. If it is positive, then only I will convert it, because reconverting it will make it positive. Then I will come here to 3 minus 1 2 is already negative. Then 1 minus 1 is 0, so at 0 the 4 I will make it 4. So now this final array that we have just created right here, if you see everything, by the way, these values would be 8 and 2 right here, right? So these are the two values, these are the two indexes where the values are positive. So those are the values that are actually missing. So if you do the exact mapping here, to the values, so 4 plus 1 5 plus 1 6, so these are the two that's missing. So here, and that's what we can return. So we'll go over this array again, and all the positive indexes, where the values were positive, that's what we will return, and just incremented by 1, because they're asking for these numbers, not indexes. All right, so that will be of solution of time complexity of n and space complexity. We are doing it everything in place, so we have brought it down to big of 1. Okay, so simple, very simple. Let's implement this. You can write the brute force. I wrote the code earlier, the pseudocode, and then you can now do the better solution. So what I will do is I will go to all the indexes for for I in range length nums. Okay, so length nums. So let's calculate the index of that value that I'm seeing right now, right? So let's calculate that. So that index would be idx would be absolute value of this nums I. Okay, this nums I minus 1, that is the index, right? That is the index. Okay, now in my nums, if this value nums I is actually greater than 0, sorry, not nums I, this index value. Okay, if this value is already if this is positive, then I want to convert it to negative value. Okay, so I will convert this at this index, the value at this index is supposed to be this nums, so I will basically negate this, so negative this value. By the way, like, do not get confused with this index. This index is taking me this index is taking me to this place where in a sorted array that number was supposed to be, but at that place I am actually negating the number. I'm negating the number, so that's the index, and for that index the value would be actually the index. Okay, not nums I, this is the value. All right, so finally what I want to return is I plus 1 for I and num in basically enumerate nums if this num is actually less than 0. So that's a list comprehension, simple way of doing that. It could be just run a for loop on your nums, and whatever index is whatever index is positive, because you have negated all the seen values, then you can return those. And here this index I is of no use, so I will just say for num in, rather than saying it in range, this is better way of going over this value, and this num, yeah, and this, and then finally this number was supposed to be actually negative, and then this comma. So that is it. So let's try to run it. Let me zoom out, and for I, if num is less actually the num is greater, yeah, my bad. So num is greater. If num is positive, that's when we are including these numbers, and then let's submit. Awesome. So time complexity, big of n, visiting all the numbers max by 1, and then space complexity is big of 1. That's what we improved from the brute force solution. So you can go over this, do a dry run, and then you'll find like how we are doing this. We are only converting that, finding that index in the array, take that value, make it negative. That marks that index plus 1 value has been visited. Okay, so let's go to AlgoYogi, mark this problem solved. See you guys later in the next problem.